Hi everyone, welcome to day 2 of polynomials. Today we're going to be talking about multiplying polynomials, and we're going to start with distributing a monomial. So the first thing we're going to do is just distribute this 3x to the third to everything inside the parentheses. So we're just distributing like normal, okay? Nothing special. Actually, that's a lie. There is something special. Because we are dealing with variables and exponents here, there is a certain thing you want to remember, okay? When we're multiplying variables now, what happens is that we're actually adding the exponents. So we're not changing the, how many variables are there within that term. We're just going to change the exponent. That will tell us how many variables are there, okay? So we'll do 3x to the third times negative 2x to the second. So 3 and negative 2 we can multiply no problem. That's just negative 6. X to the third times x squared. Well, that would be 5x's total, because there's 3 here and 2 here. So we're just going to write x to the fifth. So 3 plus 2 gave me 5. Okay, then I'm going to do 3x to the third times 5x. 3 times 5 is 15. X to the third times x, and this x, remember, has that invisible 1 that's right here as an exponent. Okay, so that means I'm going to do 3x's here and 1x here. That's 4x's total. So that would be x to the fourth, because I just did 3 plus 1. And the final one is 3 x to the third times negative 7. So I'm just going to do 3 times negative 7 and bring the x to the third down. There we go. Okay. So the 5 is from the 3 plus 2. The 4 is from the 3 plus 1. And the 3 is just brought down because I didn't have an exponent to add with it. Okay. And that's just distributing a monomial. Next we have multiplying binomials. So there's 4 different methods you can use to multiply binomials. Okay? So, and you can choose any one, not regulating which one you have to do. Okay? So, method 1 is modeling. We actually use pictures to help us come up with it. And it can be a little confusing, I know. We can go over this a little bit more. This method is more just to show you in case they ask you a question. To be very honest, I don't see a lot of you guys using this method, but if you want to, go for it. Okay? So for modeling, what we do is we actually come up with shapes, which are somewhere around here. I know they are. Here they are. And we use shapes to represent different kind of terms. So like x squared would be a big old square. The x term would just be a rectangle, and like a 1, we would just use a little square for. Okay? So, what we do is we create this little chart, and instead of using numbers, we're going to use little shapes. So, on the top, I'm going to do x plus 3, which means I'm going to have 1 rectangle, because I only have 1 x, and 3 1s, because I have a 3 here. So, I have a rectangle and 3 1s. To represent the x plus 3. Okay? Then for the x plus 6, and I know that's not a plus on your paper, just change it to a plus sign. Okay? Because I have 1x here, I'm going to do 1 rectangle, and I just do it right there. And I have 6 here, so I'm going to do 6 1s. So 1, 2, 3, 4, 5, 6. Now, to figure out what it is to be multiplied, what I'm going to do is I'm actually going to draw lines all the way across it. I'm sorry I have to do this in front of you like this. It's just how it is. So, first I'm going to draw a line straight down like this, all the way down. Then I'm going to draw another line, like cutting up these shapes basically, all the way through the entire chart. Okay? This is the more tedious one to do. However, if you really like that visual representation, it's a great method to use. Okay? Oh, and I forgot to cut this one. There we go. I just like to cut it up a little bit. Then I'll cut this guy. I'll cut this guy. Didn't say I was great at cutting, guys. Cut this one up. Cut this one up. Whew, it's a tedious job. Cut this guy, and then round it out. Okay? And if you can see, it makes all these little shapes in between. So I basically just go through and name what they are. So the big square is an x squared. This guy is an x. an X because it's a rectangle, an X. Where's my other X? It's kind of hard to see. These are all just X's that aren't showing up anymore. Probably because I cut right over them. It's kind of weird. But, you know, why be helpful? There's an X. Sorry, guys. X, X. These guys are X's because they are more rectangles. So I labeled them. And then these guys are all 1s. Okay? So I'm just labeling them all so I know what they are. It is a pain in the butt, especially on the computer, but we do what we gotta do. Label. Label. I said label it. Alright, well, you see it. So, basically, once I've labeled them all, I just go ahead and count it up. So I have 1x squared. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. Oh, sorry, not even that. I would do x squared, 3 x's here, 6 x's here, and all together there are 18 1s. So I just go ahead and write it out. X squared from here, 3 x's from here, 6 x's from here, and 18 1s. Then I just go ahead and combine my like terms, which I could do within this graph. So you guys just saw me do, because I could just count up all my x's throughout the whole thing, and I'd have 9 x's total. So that is my multiplied form. It creates a trinomial. Okay? That's modeling. Alright? The next method is using distributive property. Okay? And again, change that to a plus sign. What that says is take the first binomial, trinomial, whatever it is, the first polynomial, and distribute it to each term in the second polynomial. Okay? So I'm going to take the x plus 3 and multiply it by x and by positive 6. So when I do that, I get x times x plus 3 plus 6 times x plus 3. Then I'm going to go ahead and distribute again. So now I got to distribute this x to the x and the 3, the 6 and the 3, sorry, the x and the 3. And what I get is x squared plus 3x plus 6x plus 18. Okay? And then I go ahead and simplify. And I get, where'd it go? Doesn't want to show up. So annoying, guys. I don't get it. Why doesn't it like it? Oh, I think I know. Yeah, I think I might have figured it out. Anyway, so if you can see, I get the same answer. I actually get the same numbers going on as well. It's because I'm multiplying the same things together. It's just different ways of looking at how you're multiplying. Okay, so that's double distributing. The next one is the box method, which is yet another way to organize it. To be honest, I think this is probably the way you're going to use it the most. So because I have a binomial times a binomial, I made a 2 by 2 box. Because on top of the boxes, I'm going to put each term. So like, I'm going to do x. Oh, guys, now the properties really don't want to work. Just such a pain in the butt. I've got an x here. I've got a plus 3 here. I should just turn these off as I go. There. An x plus 3, so I just took the first binomial and kind of spread it out over 2 boxes. Then I did it for the second one. I have an x here. Oh gosh, that didn't want to show up. Guys, I don't know what's happening right now, which is so not great. I'm trying to create a video. So not fun. So, and then I take the x here, and I put the x, wow, the x plus 6 there. That one showed up. Okay? Now I'm going to go ahead and do the multiplication. So x times x gives me x squared, which doesn't want to show up. Sorry guys, I'm trying to make this a quicker video, but it might just be a lengthy one. And now it doesn't want to be clickable. There we go. X times 3 gives me 3x, which won't show up. 3x. X times 6 gives me 6x. And 3 times 6 gives me 18. Once I've filled in all the boxes by multiplying the terms together, I can just take all the boxes and lay them out, okay? So, x plus 3x, because it's a positive 3x, plus 6x plus 18. Then simplify, and I get x squared plus 9x equals 18. Okay? So that's method 3. The final method for multiplying binomials is FOIL. Now warning, this method only works with 2 binomials, so you can only use it for binomials. Okay? So when you have 2 binomials, you can use FOIL, which stands for first, outer, inner, and last. That's what FOIL stands for. Okay? It basically can help you know what to multiply together to create your trinomial. So, first means I'm going to do the first term from each binomial. So x and x. Multiply x times x, I get x squared. Outer means the outer terms of each binomial. So x and positive 6. So I multiply that together, I get 6x. Inner means the 3 and the x, so the 2 inner terms, 3 times x. And last means the last term of each binomial, so 3 times 6. And that gives me 18. Now I'm going to take what they all equal and make it into one polynomial. So I get x squared plus 3x plus 6x plus 18. Then I combine my like terms in the middle here, and I get x squared plus 9x plus 18. And that's my simplified form. Okay? You guys are going to try these two on your own. You can use any of the 4 methods I just showed you. It is up to you. My suggestion would be to practice a different one for each one. Okay? And we will talk about those different methods in class. The next thing we need to talk about is multiplying a binomial by a trinomial, very similar to what we just did with 2 binomials. Okay? There are 2 methods. 2 methods you can use. You could use modeling if you want. I wouldn't suggest it. So I would just stick to these 2. So you can double distribute, which means you're going to take the first term, or the first binomial, and multiply it by each term in the trinomial. Okay? Did I do it? No, I didn't make my arrows. So I would do x plus 4 times x squared, x plus 4 times 2x, x plus 4 times negative 6. And I get this. Okay? So I'm multiplying the binomial by each term. Then I'm going to go ahead and distribute again for a second time. So each binomial is getting distributed, or we're distributing the number in front of each binomial. So x squared times x, remember that's when you're adding the exponents again. So that has an invisible 1 here. So you get x to the third. X squared times 4 is just 4x squared. 2x times x is 2x squared. 2x times 4 is 8x. Negative 6 times x is negative 6x. And negative 6 times 4 is negative 24. A lot lengthier. Okay? Last thing you do is combine your like terms. Okay? So 4x squared and 2x squared will give me 6x squared. And 8 minus 6 will give me 2x. And that's as far as I can go. That's as simple as I can get it, by just multiplying it out. Okay? The next method is using the box method again. So because I'm doing a binomial, I'll make it 2 high, and a trinomial, I make it 3 boxes wide. Okay? Then I fill in the sides, so an x and a positive 4. An x squared will go up here. A 2x will go in the middle, and a negative 6 will go on the end. And then I just go ahead and multiply. X times x squared gives me x cubed. X times 2x gives me 2x squared. X times negative 6 gives me negative 6x. X squared times 4 gives me 4x squared. 2x times 4 gives me 8x. Negative 6 times 4 gives me negative 24. Where'd it go? There, way down there. Okay, whatever I have in the boxes, I'm going to write out. So I have x cubed plus 4x squared plus 2x squared plus 8x minus 6x minus 24. Just like in the first method, got the same numbers. I'm going to go ahead and combine the same ones, and I get the same answer. If it will show up. But it doesn't like to show up. I don't know why. It just really doesn't like me today. There we go. And show. There we go. Okay? So both methods will give you the same answer. You guys are going to try this one on your own. Finally, it's just dealing with area. Okay? Remember area, we do length times width. So we're just going to do 4x plus 8 times 2x plus 3. I just set it up like that. So I can do this like any of those four methods I showed you when we multiplied two binomials. You can set it up any way you want. Whichever way you do, you should be getting these four terms. 8x squared plus 12x plus 16x plus 24. You should get those four terms, whichever method you choose. Then I can go ahead and combine like terms. I get 8x squared plus 28x plus 24. Okay? And then you guys will try the last one on your own as well. Same formula for the area of a rectangle. Okay? If you guys have any questions, please write them down. I will see you next time. Have a great day.